Okay. Ooh. Yeah. Let me share my screen first. Okay, 4.3 there. Okay, so what was the error you had?
Last one I did is the one I checked the most. 4y to the fourth plus 5y squared minus 1. That's divided by y minus 1/4.
Okay.
Fractions stayed relatively.
What method did you use?
Well, synthetic division.
All right. Yeah, we can use synthetic division because there's no coefficient, no fraction, no anything. No exponent. So since we use it, we use the opposite of what's there already. So it's a positive 1/4. Okay, our first one is going to be to the fourth. So the coefficient is 4. There is no third. Y squared is 5. There is no y, and -1. That's the first step. Start off by bringing on the first one. Now multiply. 1/4 times 4 equals 1. So that goes there. Now we add. 0 plus 1 is 1. We repeat the process. 1/4 times 1 equals 1/4. Now we add. 5 plus 1/4 is the same thing as 20/4 plus 1/4 is 21/4. Multiply 1/4 times 21/4. Nothing cancels top and bottom, so we multiply. 1 times 21. 4 times 4 is 16. So
16.
you put 4. We add. You get 21/16 and multiply. 1/4 times 21/16. Nothing cancels. 1 times 21 is 21. 4 times 16 is 64. Since now we add, we have -1 plus 21/64. This one's going to be -64/64 plus 21/64. Since 64 is bigger than 21, the answer is going to be negative. 64 minus 21 is 43. And that should be it. That's your remainder.
Maybe I was just getting frustrated and I messed up my multiplication.
No, 4 times 4 is not 8 now.
And number 8, that's the one where they tell you to plug in 3 different F's. Maybe I wasn't.
Okay, let's look at number 8. f of x. F of x equals x cubed minus 13x squared plus 52x minus 60. We have to find f of 2, f of negative 5, and f of 6. Use synthetic division. Remember, whatever's inside the parentheses goes outside of our dividing line. Yeah, so our coefficients are 1, that's for the x cubed, negative 13 for the x squared, 52 for the x, no, yeah, and then negative 60. Bring down the first term. Now multiply addition. 2 times 1 is 2. Negative 13 plus 2 is negative 11. Multiply. 2 times negative 11 is negative 22. Add. 52 minus 22 is 30. 2 times 30 is 60. Negative 60 plus 60 is the remainder 0. So we know that x minus 2 is a factor. And the remaining term is x squared minus 11x plus 30. We have to figure out that one next, which is easy. We could factor that out. Since they're both the signs are the same, they're both negatives. What times what is 30? That when you add them, you get 11. So x equals 6, x equals 5. Now, is there another way we could have tested to see if this is a factor?
So that would be that x squared minus 11x plus 30, right?
Well, no, if you plug in the function, you'll end up with 0. This is the answer. If you put in f of x2, you'll end up with 0.
Well, no, when it goes into MATLAB, the way
Right, yeah. So what you have left is this x squared minus 11x. So it'll ask you, what is the q? What is the quotient remainder?
the thing I want to see is how you're putting in the remainder. It doesn't have a different box for remainder. It leaves just one box for it all.
Oh, okay.
It's just adding it to the end.
Okay, this one here is going to give us a remainder. So let's look at that. Since we know 6 is going to work, it'll give us 0. I'm not going to waste my time with that. So we'll try negative 5. 1, negative 13, 52, negative 60. Bring down the 1. Negative 5 times 1 is negative 5. Add negative 13, negative 5 is negative 18. Negative and negative is positive. 5 times 18 is 90. Add. Now, negative times positive is negative. 5 times 142. And if you add them, they're both negative. So it's 770. So the way you put the final answer, it'll be, remember, it always starts off, the answer starts off with 1 less than the original equation. So it's x squared minus 18x plus 142 minus, since that's the remainder, it's 770 divided by x plus 5. That's the remainder.
Yes.
Yeah, because remember, whatever's over here is your 0, is x equals -5. So when we add it to both sides to get 0, that's your denominator. All right. So far, let's review what we've talked about so far. If I gave you, let's say the one we just had. What can you tell me automatically just by looking at this? The shape, the direction, the y-intercept. Just by looking at this, you can tell me this much so far. The maximum number of intercepts, the maximum number of solutions, the maximum number of turning points. Now, all this comes from the leading term and the constant term. So what's the shape going to look like? What's the degree of the equation? The degree is 3. What is A? A is greater than 0 because it's 1. So because it's odd, and we know the direction because it's an increasing equation. It's odd, so we have 2 ends pointing opposite directions. The y-intercept we know is -60. Y equals -60. The maximum number of intercepts and solutions are the same thing. The maximum number are 3. The number of turning points is always 1 less than the number of solutions. So we know this, what the basic shape is going to look like already. Only thing we have to do now is figure out what the x-intercepts are. That's the whole part. And that's what we did up here. The x-intercepts. Because once we factor it, we'll get a whole bunch of these binomial expressions, linear binomial expressions. And to save time for this one, we know we had x minus 2 is one of them, x minus 5, x minus 6 are the other two. Set it equal to 0. I'm using this one as a stepping stone because we know what the answer is supposed to be already. So what are my x-intercepts? It's the opposite of what's inside there. 2, 5, and 6. Okay, well, we know We knew from this one that f of 2, when x is equals to 2, when x is equal to 2, when x is equal to 2, that this is a solution. So we set that over there. So it's x minus 2 equals 0. We did that. We got that first equation. What was left from our work was this quadratic equation. We factored that out. So since that's x minus 6, solving it for 0, set them equals 0 and solving them, you get x is 6, x is 5. So those are our three solutions. So basically, if I give you the solutions, you can tell me what the intercepts are. I mean, you can tell me what the equations are. Just by, if it's x equals 2, then just x minus 2 goes inside the equation. If it's x equals 6, it's x minus 6. If it's x equals negative 5, what equation does that come from?
X plus 5.
Right. And if we had a fraction, this is always your leading term coefficient. So it's 3x, and it's opposite this sign. So it comes from 3x minus 2. The bottom number goes in front, and the top number just changes sign. You would have, after doing about 10 or 12 of them, you see the pattern. What's shortcut? Instead of, okay, I have this, I multiply both sides by 3 first, then I subtract 2. After you do that a couple of times, you'll see there's a pattern. It's always the bottom number goes in front, and then the top number just moves over. Remember, mathematics is a bunch of patterns. So, okay, we have the x-intercepts. We also have the multiplicities. What are the multiplicities of each of these? 1, 1, 1. So what does that tell us about the graph?
It's odd, so it grows.
Yeah, since the multiplicity is odd, so we know the line crosses the x-axis at these points. So there's another thing we know. So the multiplicities are the exponents, and the solutions are those, the x-intercepts. Okay, so let's go back to where we ended up last time. We're going to use this example again, and we're going to start from the beginning on this one. Okay, you have a polynomial. You have any number polynomial. P of x, x to the n, plus all these other things, you get to the very end, you have q of x. A constant term, actually, it's just q. We need remember, we need to have P and Q defined. What is P? P is the leading coefficient. P is the leading coefficient, and Q is the constant. And all you have to do is put the absolute value of it, because we're going to take a plus or minus of each one. What we have to do is look for all the combinations, the prime not really the prime factorizations, but the factorizations of each of these numbers. So 1 just breaks down into 1 by itself. But 60, it can be 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and then 6 times 10, 7, 8, 9, 10. Now then we go back up to 10. So those are all the possible. So 60 can be 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Those are all the possibilities of what could happen. So that's what 60 breaks down into. So you factorize each of these, see what they're made up of. What we have to do, we have to find all possible combinations of that. The plus or minus, because it could be positive, it could be negative, of Q over P. And fortunately for us, P is 1. So it's going to be, it could be plus or minus 1, plus or minus 2, plus or minus 3, 4, 5, 6. Okay, it seems like a lot, but think about it. How many possibilities did we have before this? Infinite number of possibilities. We don't know anything about that. So there's infinite many numbers we can pick. Now we just narrowed it down to these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, these 24 possibilities. But we also know something else. How many of these are going to be the right answers? Since the degree is 3, we're only going to have 3 of these are the answers. Since we know only 3 of these. Once we find the first one, then we have a quadratic equation. Now we can use a much shorter method. We can either factor it or use a quadratic formula. So we've narrowed it down and we go a lot faster here. So we start with the first ones. Let's try positive 1 and negative 1. One, negative 13. We're doing a synthetic division here. So bring down the first one. 1 times 1 is 1. Add those, get negative 12. 1 times negative 12. Add those, you get 40. 1 times 40 is 40, you get negative 20. Since the remainder is not a 0, we know that plus 1 doesn't work. Do the same thing with the next one. Bring down the 1. Negative 1 times 1 is negative 1. That's negative 14. You add straight down. Negative times negative is positive. 1 times 14 is 14. 66. Negative 66 equals negative 126. And that's not going to work. So we know 1 and negative 1 don't work. So I go across line. -2, or I said +2 and -2. One -1352, -60 for both of those. And just use synthetic division on. So we have 1, so it's 2, makes it -9. Positive and negative is negative. 2 times 9 is 18. 52 minus 18 is 36. 36 times 2 is 72, makes it 12. So that doesn't work. Two times 1 is 2, -9, -18. Oh, it's 34, I'm sorry. That's 34. So it's 68, which makes it 8. Bring down the first one. -2. This makes it -15. Negative is positive, so it's 30. -44. Did I miswrite down the question? 30, 13 is 1, -13, 52, -60. 2. That's where I messed up. You guys didn't catch me. This is not -9, it's -11. So it's 1, makes it -11. This makes it -22. Then 60. So that's how we know this is a correct answer. Since the remainder is 0, we know x equals 2 is a solution, is an intercept. So x minus 2 is a factor.
So once you establish that one of the positive or either the negative, you don't have to try to figure out the opposite, would you?
No, sometimes it could be both of those, positive and negative.
Oh, okay.
Actually, it could also be this one again. It could be that one again. It's just that I see what you're saying. The question was, once we find the first one, we don't have to try the opposite of it. Yeah, but sometimes it would be the opposite one.
I've had a problem where it was the +2 once again. In fact, it was the +2 3 times.
Yes. Okay. Now, see, once we get to this point here, once we get a 0, we're done with the original equation. We're done with that. We only have to worry about this equation now.
Correct.
We can repeat the whole process and get a whole new ratio. So now it gets a little bit smaller now since we don't have 60 anymore. We know 60 won't work. We know 30 won't work because 1 doesn't work. So if it doesn't work for the first one, it won't work for any subsidiary ones afterwards. Because remember, this is also going to be important. Since our equation now is this, we can use the quadratic formula and either use the quadratic formula or just try to factor this out straight up. Yeah, because every step you go down, the answers get a lot simpler. It's just getting the first one out, because we haven't gotten to an example where it could be a fraction. Those are the horrible ones. Now, do you have to use synthetic division all the time to test these? Use substitution, yeah. If I plugged in 2 in place of my equation and hit enter, I get 0, since I know then that's one of my intercepts. That's the fastest way you can do it. If you use Excel or something like that, or if you know how to program your calculator, or I've just put another X in there and see what that works. Or you can keep on doing synthetic division. All right.
If you had a problem with x to the 4th that began with 4, and then you did the division until you got it to another problem that was cubic, could you still continue to factor? And then you would do use the quadratic formula after that point?
If you start off, do you remember what the equation was originally?
Yeah, x to the 4th minus 2x cubed minus 12x squared plus 40x minus 32.
Woo, I'm sorry, everybody. It just got really weird. Okay, so it said use synthetic division, or did it give you any f of x to sample?
No, they want you to factor it out and then use synthetic division.
Okay, so remember, we have to figure out what P and what Q are. What's P?
P is x to the 4th. 1 x.
Yeah, P is the leading coefficient, and Q is the
32
constant. So when you factor these out, our P is the easiest one. Mm-hmm. It's this one, so we're lucky there. So we have 1 times 32, 2 times 16, is there anything else? 8 times 4. 5, 6.
Let's see, 2, 4.
That's it. Because if you factor any of these guys, it's just, yeah. So we have 1, 2, 4, 8, 16, 32. Now we take all possible combinations of Q over P. So 1 over 1, 2 over 1, 4 over 1, 8 over 1. Notice I put in plus or minus in front of all those. So that's why last time since it's over 1, I just put the leading the numerator. And how many answers are we supposed to get here? Or maximum?
Maximum of 4.
Maximum of 4. So we'll begin. We're going to do positive 1 and negative 1. So we have 1, negative 2, negative 12, 40.
Do we need to put it in at 0 in between x and x?
There's a negative 12.
Okay, I got
4, 3, 2, 1, 0. Yeah. So it's 1, negative 2. Yeah, and if an exponent is missing, you have to put a 0 in that place to hold that spot. Bring on the first term, multiply 1, add, multiply is 1 times -1, add, down. 1 times -13 is -13. Add is 27. So answer would be -5. That doesn't work. So 1 doesn't work. -1 times 1 is -1. -1, add these, you get -3. -1 times -3 is 3. So multiply these. Add those. -12 plus 3 is -9. -1 times -9 is 9. It's 49. -1 times 49 is -49. It's going the wrong direction. -81. So it's neither of the ones. So we'll try 2 and -2. Just write down what's inside my synthetic box. Bring down the first term, multiply. 2 times 1 is 2. -2 plus 2 is 0. Add straight down. 2 times 0 is 0. -12 plus 0 is -12. 2 times -12 is -24. And add. 40 minus 24 is 16. 2 times 16 is 32. So there's our first answer. We could, since we have it written out, we go ahead and work this one out also, just in case it's a -2. So -2 times 1 is -2. So this is our first one. Add those, you get -4. Negative and negative is a positive. 2 times 4 is 8. -4. -2, -4 is positive 8. 48. -96. It's going to be, so that's not going to work. If it doesn't work on the original one, it will not work on the subsidiary ones. So our new equation that we're going to be dealing with is that one. From here on out, now, but once we got the first one, look at our list. Well, we finished the 2's also. Which ones can we get rid of any of these numbers to try?
We should try 4.
No, we can get rid of the 34.
Yeah.
Because that's bigger than 16. So, and since there aren't any fractions, we know a 34 won't work. So we've now just knocked off 2 more. Now, typically you'd start off with 4 since you tried those, but it's very possible. Remember, it's at most, and it could be down to 0 possibilities. So we start off with the ones that work.
So
always start from there. What's that?
I'm sorry. Before you go into synthetic division, is it x cubed, and then you have a blank, and then you have 12 minus 12x? Okay.
Right. That's your new equation.
Okay.
Yeah, and that one turns into this. Exactly right.
Plus 16.
Okay, so we bring on the first term. 2 times 1 is 2. Add those. 2 times 2 is 4. Negative 12 is bigger, so 12 minus 4 is 8. 2 times negative 8 is negative 16. So we know that. Now that's our new equation. Looking at this, can we get rid of any numbers on our list? Look at this last number in our equation. Can 16 go in there?
No.
No, it's too big.
So that becomes x squared minus
X squared plus 2x minus 8.
plus 2x.
Right, we reduce it again because we start off with x to the fourth. We lost an x because of that's a solution. We lost another x, so we have 2 more left. Now we can either keep on going synthetic division, or we can try to factor this one out. X plus 2x minus 8. Is it factorable? You know, x and x, what signs go in there? They're going to be opposites. Right, the bigger number. So what times what is 8? When you subtract them, you get 2. Mm-hmm. We have 1, 2, 3, 4 solutions. Since this is x equals 2 as a solution, the factored form is x minus 2. Since this is x equals 2, it's x minus 2. So our answer looks like this: x minus 2, x minus 2, x minus 2, x plus 4. X minus 2 cubed, x plus 4 to the first. Now, why I put it in this multiplicity form? Because now we know what happens at our intercepts. At positive 2 and negative 4, does the graph cross or touch? They're going to cross. Because the multiplicities are odd, the line's going to cross at those 2 points, at 2 and negative 4. Yeah, so my zeros are at 2 and negative 4. The multiplicities are at 3 and 1. Yes. Now we can't. We have a rough sketch. What's going to look like.
What's the multiplicity again?
Multiplicity is the exponent. Once we have this, since we say x minus 2, x minus 2, x minus 2, there's 3 of them. The exponent of the parentheses, that's your multiplicity. One, two. We have 4 terms because we have a 4th order equation. So the multiplicity, since we have the same answer occurring more than once, we just condense it and use the multiplicity, the exponent. And for the solutions, well, the same way, I mean, how did you do earlier when you put the other ones when we asked for the intercepts of the solutions? It'll tell you if it wants it in a binomial form or as an integer. If it's asking for an integer, then you just put the numbers. X equals, it'll still say X equals, and here's the box. You could put 2 and 4.
Yeah, on the quiz, it's going to ask you in binomial form. So you will have to write it on x minus 2 cubed.
Yes, yeah. So you said on the quiz, it'll ask you for binomial form. You can either put it this way or this way. So let's see what the rough sketch is going to look like. We know the degree is 4. So what does that tell us about the shape of the curve? They're going to go the same direction because that's even. Since that's the coefficient's positive, they're going to point up. So we know the graph is going to have both ends pointing the same direction. So we have our x-intercepts at -4 and 2. We have our y-intercept at -32. We know that at the end behavior, they have to point the same direction. How many vertices we're going to have at most? Number of vertices equals n minus 1, which is 3. At most 3. Vertices are turning points. So when I say vertices, they say turning points. So this graph, until we plug in some numbers, it could look anything. What's below this line? Only thing we know for sure is it has to cross through that point. Whether it's going up or down, we don't know yet. That comes from plug and play. All right, let's look at the last couple of ones we did. Now we're going to get to the next part. That one, yeah. Okay, so far, what have we done? By looking at n, we know the maximum number of solutions. We also know the maximum number of x-intercepts. N minus 1 gives us the maximum number of turning points, or vertices. If A is positive, A is negative, it tells us the direction. Oh yeah, N also tells us the shape. If N is odd, then N behavior points different direction. If N is even, then they both either point up or they both point down. So let me write down the equations that we've had so far that we looked at. And then I'll also put the answers down. So the first one we looked at, or the second one that we solved, The solutions here were x equals 2, 5, and 6. And the second one we looked at. X to the 4th minus 2x cubed minus 12x squared plus 40x minus 32. The solutions there were x equals 2, 2, 2, and negative 4. Because now I want to show you another trick, not a trick, but another procedure to narrow down the possible numbers we have. Since we know n tells us the number of solutions, but there's infinite and many number of them. So we then go to the rational zeros. This is called the rational zeros, because if you put those numbers in the equation, the answer is 0. Those are intercepts. Even when we did that, we had a whole bunch of them. That was still a long. Let me see. Let me write those down. So the possibilities were 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. And for these, we had plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, 16, 32. So you see how, okay, we've narrowed down from infinite number of possibilities to these, from an infinite number of possibilities to these. There's one more step, one more rule of thumb that could now narrow it down even further. What if I could determine the maximum number of positives or negative answers that you'll have? That's the third step. Number of positive and negative solutions. Descartes rule of signs. Descartes. D-E. Descartes. C-A-R-T. C-A-R-T-S. Do you ever hear the, what is a cartographer? Anybody know what that is? It's a map maker. If you ever look at a map, you know it's made up of a grid. Horizontal and vertical lines. Same as our XY axis. That's how it came cartographer, with Rene Descartes. Rene Descartes. What the rule of signs says is this. number of sign changes equals the number of possible answers with that sign. Okay, what does that mean? Let's look at the first example. Let's look at this example. This is example 1, and this is example 2. How many sign changes are there? From positive to negative, that's 1. From negative to positive, that's 2. From positive to negative, that's 3. Okay, so since X is positive, we can have 3 or 1 positive solutions. Because this tells us the maximum. Whatever the maximum is, always subtract 2 because it always comes in pairs. Yeah, because whatever you get, since answers come in pairs, that's where we take 3, subtract 2, you get 1. If I had, let's say 7, I could have 7, 5, 3, or 1 solutions that are positive. So whatever number you come up with, that's the first one, that's the most. Then you subtract 2, it could possibly be that many also, because they always come in. I'll show you why I come in pairs. So if you had 7, then you could have it at most 7 or 5 or 3 or 1. So always subtract 2. How about this one? How many positive answers are we going to get there? Is that a sign change? From positive to negative? That's 1 sign change. From negative to negative, is that a sign change? No. From negative to positive, that's another sign change. From positive to negative, that's another sign change. So the number of positive answers can be 3 or 1. All right, so that's how you figure out the positives.
Yeah, to be honest, I don't know how that helps us. Because
It helps us because once we know we have 3 positive answers, that means if we have 3 positive answers, how many negatives can we have?
just 1. Okay.
Once
Yeah.
we find a negative 1, then we don't have to do negatives anymore.
Okay.
So let's say -2 was the answer. I don't have to try -4, -8, -16. I don't have to try anything else after that.
Okay.
So it decreases the number of possibilities we have from there.
So for the second, once we find out that there could be 3 positives and 1 negative, or we found out that we have 3 positives, then we could find out that we just need 1 negative.
Right.
At that point. Okay.
Actually, it's either going to be 1 or 3, because together these things have to equal 4. But this will give us another, we know it can't be because you have to only go down. So we know it can't be 3. So this has to be the correct configuration. We know we're going to have 3 positives and 1 negative answer. And sure enough, that's what we have. But let me show you how to make sure for sure on how to test for negatives. to test for negatives. Place a -1 in place of X. So we had not in place, but in front. So now we're going to put -X. So it's -X cubed minus 13 times -X squared plus 52 times -X minus 60. Now, a negative, when you cube it, is that going to be positive or negative?
Negative.
Negative. So it's -X cubed. A negative, when you square it, disappears. So we have -13x squared. So a negative times a positive is a negative. How many sign changes do we have now? Is that a sign change? No. Is that a sign change? No. We'll just look at the signs between the numbers. So the negatives will have 0. And sure enough, that's what we've determined earlier. Because it's a third order equation and our positives were 3 or 1. That means the negatives have to be 0.
So that becomes your first step now.
Actually, you can do it any along any line you want to, but yeah, it's definitely do it before you start doing the synthetic division, because this will tell you how many answers you're looking for. Let's look at the other equation. It's -x to the 4th minus 2 -x to the 3rd minus 12 -x squared plus 40 times -x minus 32. So a negative to an even power cancels the negative, so we just have x to the 4th. Negative to the 3rd power makes it negative, so negative times negative makes it positive. Negative squared makes it positive, so that one stays. Positive times negative is negative. Look at the sign changes. Positive to positive, nope. Positive to negative, that's 1. Negative, negative, nope, nope. So for the negatives, we'll have 1. And for the positives, we'll have 3 or 1. Since that one's 1, that can't be it. So it narrows down our possibilities that we have to look for later on. Is everybody okay with what I did here? If the exponent is even of a negative number inside the parentheses, so -x to the 4th power is simply x to the 4th, because that cancels. Even powers cancel negatives. If it's odd, then it remains a negative. So if it's even, the negative sign disappears. If it's odd, the negative sign stays in front. So this, again, now we've gone as far as we can to make things easier for us. The rest now is up to you.
Yeah, and this helps a lot because on question 11 in our quiz, it took me, what, an hour to answer it. It almost feels like that.
Oh yeah. When the numbers, when P and Q are large, have multiple factors, yes, then yeah, you have a lot of working out to do. But this helps narrow it down. Right, a question?
So we could just start substituting possible answers without doing divisions.
Yes, if you want to, but see you can. The question was, can we just start substituting without doing synthetic division? Yes, you can. But once you find one that's 0, go ahead and do synthetic division because it makes the equation smaller. So that way it makes it, you'll see what you have left. Or you can keep on using the big one, just plug in your calculator and kick it all out. Oh, okay. Let's work backwards. What is the degree of the polynomial with solutions at x equals 3, -5, and -1? Then the second question I'm going to ask you with this, what is the polynomial? There's 2 questions. This makes us work backwards. Since we know these are our solutions, these are our X-intercepts. Since they're solutions, they're X-intercepts. They're also zeros. Solutions, X-intercept, they're all the same thing. So take each of these, solve them for 0. In other words, subtract 3 from both sides. X minus 3. Add 5 to both sides. X plus 5. Add 1 to both sides. Because we want them to equal 0. Now we know our polynomial is made up of x minus 3, x plus 5, x plus 1. So what, knowing this much, what's the degree of it?
It's going to be 3.
Right. The degree at this point, add up all the multiplicities and we get the degree. So since it's a third degree equation, we know that the highest exponent that we have will be x cubed. So now we just multiply these together. So now we just multiply those together. Well, I said, I'm going to show you. It goes back to what we did the first day of the semester.
2 and set 1 to the side.
Yep. Order of operations. This is the same if I gave you 3 times 4 times 5. You'd multiply these 2 together. And then these 2 together. You do the same thing here. Let's just multiply those 2 together first. it's going to be in its own parenthesis. So x times x is x squared. X times positive 5 is positive 5x. That's done that one. Now negative 3 times x is negative 3x. Negative 3 times positive 5 is negative 15. Whenever you get rid of parentheses, first step is always combine like terms. Positive 5 minus 3 is positive 2x. Repeat the process. X squared times x is x cubed. X squared times 1 is x squared. So that's it for that one. 2x times x is positive 2x squared. X times x is x squared. Positive times positive is positive. 2 times 1 is 2x. That does it for that one. Negative times positive is negative. 15 times x is 15x. Negative times positive is negative. 15 times 1 is 15. We got rid of parentheses, so combine like terms. These guys and those guys. 2x plus 1x is 3x squared. 2x minus 15. 15 is bigger, so it's negative. 15 minus 2 is 13 x's. And there's your polynomial. That's how it works. So if I give you the solutions, you can tell me the function where it came from. Now, remember earlier I told you when we looked at the rule of signs, let's say if we had 5 positives, what other possibilities could there be? I told you always subtract 2. And here's the reason why. Let's review. Let's review back to complex numbers. And remember what a complex number is? A plus bi, right? That's a complex number. We learned how to add, subtract, multiply, and work with those. There's something called the complex conjugate. I told you we'd do division later on. Whenever you divide complex numbers, a rule about complex numbers, another one I should say, is you cannot have an I in the denominator. You cannot have an I in the denominator. Review real quick. What does I squared equal?
Square root of I.
One.
-1. You guys are getting close. Yes. Because whenever you see an I squared, just replace the I squared with a -1. So let's look at division. 2 over 3i. Because you cannot have an I on the bottom, we have to multiply the top and bottom by 3i. It's really just I, but it makes it much easier if we make 3i. Now you multiply. 2 times 3 is 6i. 3 times 3 is 9. I times I is I squared. Can anything cancel? Well, yeah, that I squared becomes a -1. So because there's a negative inside there, the whole number is negative. But 6 and 9, we can simplify there. They both have what in common? They both have a 3. So it's 2 over 3. So it's 2i over 3. There's your final answer. So I could have just said you multiply top and bottom by I, and we get to the answer, but it's just like complex. A lot of people don't like that. So I said just multiply the bottom, whatever the bottom is, multiply top and bottom by it. So whenever you have a monomial, a complex monomial on the bottom, whatever that is, multiply top and bottom by that, and it's going to get rid of it. Okay, I introduced complex conjugates. Conjugate in mathematics simply means, in layman's term, opposite signs. So if I gave you A plus BI, the conjugate is going to be A minus BI. That's the complex conjugate. Multiply them. It's multiplied. But let's go ahead and work this one out. We don't need numbers. Let's leave it as letters. A times A is what? A squared. So A times A is A squared. A times negative BI is negative ABI. Doesn't mean positive times negative is negative. A times B times I. That does it for the first one. Now the second one. Positive times positive is a positive. BI times A is ABI. Positive times negative is a negative. BI times BI is what?
BI squared.
B squared, I squared. Very good. So we combine like terms. The ABIs cancel. And I squared becomes what?
-1.
-1 times negative B. Change it to a positive, and there we have it. The complex conjugate gets rid of the I. Whenever you multiply anything by its complex conjugate, what you really have is the square of both numbers, and you add them together. Okay. I know people hate letters. So let's put numbers in its place. 2 minus 5i. There's your complex number. Multiply it by its conjugate. What is its conjugate?
2 plus 5i.
2 plus 5i. Very good. I just multiply. 2 times 2 is 4. Positive times positive is a positive. 2 times 5 is 10i. Now, negative times positive is negative. 5 times 2 is 10i. Now the second one, negative times positive is negative. 5 times 5 is 25, I squared. Combine like terms, the 10 i's cancel. There's an I squared. So it becomes a -1. So that becomes a plus 25, 29. Notice there's no I in that equation, that answer anymore. That's the whole purpose of the conjugate, complex conjugate. Again, the shortcut method would have been just take your leading term and square it and add the second number. 4 plus 25 is 29. That's the fast way of doing it. Okay, what's that answer going to be? Mm-hmm. 3 squared plus 4 squared. 9 plus 16, 25. Or you could go ahead and do the foiling method. Now, what is the reason I showed you this for? What if we had that? Remember, the rule says we cannot have any i's on the bottom. Now, this is called this is how we rationalize the denominator. Whatever we multiply by, since we have I on the bottom, what do we have to multiply by to get rid of it?
4 minus 3i. Multiply the top
4
by it.
minus 3i, but it has to be on top and bottom. What is 4 minus 3i divided by 4 minus 3i? 1. So all you're doing is multiplying by 1. Nothing changes. But you have to do top and bottom, whatever you multiply by. Three times 4 is 12. Positive times negative is negative. 3 times 3 is 9i. Four times 4 is 16. Positive and negative is negative. 4 times 3 is 12i. Positive times negative is positive. Times positive is positive. 3 times 4 is 12i. Positive times negative is negative. 3 times 3 is 9i squared. 16 minus I squared. I squared is -1. So basically, whenever you see an I squared, the rule of thumb is this. When you have an I squared, just drop the I squared and change the sign in front of its coefficient. That's all it'll save you from changing -1 and everything else. And there's your answer. Okay, now, the last thing I want to tell you here is this. Notice how whenever we have this, we have to have another equation. Complex numbers always come in pairs. This is an important rule. Complex numbers always come in pairs. If my solutions were 3, 5, and -1, what's my degree of that equation? Yeah. If my zeros
When
were,
you're counting those, like on the problem we had when 2 was the answer 3 times,
right.
does that ever come up?
Well, if I did that, yes, it's a very good question. If 2 is a multiple, or if you have repeating answers, then in this case, you'd have to either write it this way or 2 with multiplicity 3. Now, this is how you typically see it in textbooks and things. You'll see 2 with multiplicity 3, which means it happens 3 times. Very good question. I'm glad you asked.
Thanks.
So what's the degree of this one? How about 3, 5i, -1i? What's the degree there?
Is it gonna still be
3.
Because they come in pairs. So if I have a 5i, then I have to have a -5i. Since I have a -1i, I have to have a +1i. This is how come the rule of the signs always subtracts 2 from whatever you have, because in case one of your answers is a complex number, you'll have one of each. So that's why you subtract by 2. So be very careful. Whenever you have an imaginary number, it has to be a positive of it and a negative of it. Okay, last thing. List all of the binomials, the parenthesis equations. If I gave you this, what would this look like? I want all these in parentheses, however many they are.
X minus 2.
Right. This one's easy. It's x minus 2. Let's do this one also. What's that one going to be?
X plus 3.
X plus 3. Yeah, so those are the easy ones. Now these guys. 3 plus 4i. What's its conjugate?
3 minus 4i.
3 minus 4i. All you do is change the sign in the middle. Then we have -6 plus 5i. So it becomes -6 minus 5i. So don't worry about the leading term. It's the sign in the middle that changes for a complex conjugate. All right, let me.
And none of these are graphable, right?
No, oh yeah, very good. Yes, because when you have imaginary, now you're talking about 3 dimension, more than 3 dimensions, because you can't graph an imaginary number. If I give you a 2-dimensional graph 3i, I put it up here. So yeah, those are non-graphable. Those are not real solutions. No, I'm going to see what else there is. Because the last parts we have are finding zeros of polynomials, which is where you put everything together, rational functions, and polynomials and rational inequalities. We'll finish this up on Monday. It's just, I need you to understand this part first, because once you understand this, the last 3 sections is just put it all together and we're done. Again, that's chapter 4. Let me switch over to the screen now. Chapter 4, we're right here. We just did polynomial divisions, zeros of polynomials, rational functions, and then this is stuff we're going to finish up. I've covered some of this stuff already, but now I want to put it into these particular terms. Chapter 5, inverse functions, exponentials, logarithmics. They sound difficult and ugly, but they're not. These are very, very, very tame. Once I show you what they really mean, it's pretty much the simplest thing we've done in a very long time. Then in chapter 6, we talk about systems of equations. We have more than one equation, and we use Cramer's rule to help us solve those. By systems, you guys remember ever hearing of the substitution or the elimination methods? Okay, we'll cover those. Again, it sounds difficult, sounds ugly, but it's very straightforward to the point. And then pretty much after that, the semester is pretty much gone and done, because these are just, you look at the equation, see a pattern, and it forces you to put it in the equation. If we don't have time for these, we don't have time for these. These are always in the very end of the lectures, because as long as we just touch on them, you have the basic idea. That's what's important, but we'll have plenty of time. So next time we're going to finish chapter 4, and then we'll start chapter 5 and finish it the week after. And then what's that?
I haven't looked forward, but from what I remember from inequalities, that you typically sometimes have incongruent lines.
Yes.
So, but that wouldn't be a polynomial anymore. I mean, that wouldn't.
Well, actually, no. Whenever you have rational polynomials, you can have what are called asymptotes.
Okay.
Asymptotes are holes in lines. Drive safe. Asymptotes are holes in lines where the graph cannot exist. At this point here, let's say it's 2. An asymptote is where the denominator equals 0. That pretty much sums it up on an asymptote. It's where the function's undefined.
Okay.
So the graph can exist on both sides, or we can have a graph that looks like this. This graph is 1 over x squared. You cannot have a 0 on the bottom. So since x cannot equal 0, that's an asymptote. The graph will get very, very, very close to it, but won't touch it. And that's what we have to identify zeros, and asymptotes when we deal with fractions with polynomials
Okay.
and inequalities. Once we have those done, then it's just a matter of looking, where is it above, where is it below the graph, the x-axis. Like, it sounds like a lot of hard work, but once we break it down, you'll see it's just straightforward steps.
Yeah, in the past, it's always been if it's something's been included or not included with.
Yes, that goes with the asymptotes, the asymptotic behaviors.
Okay.
But yeah, we'll cover that in Absterdium. We're gonna go through so many examples of those. You guys will do it in your sleep. All right, everybody. Any more questions? Then I will see you all. Oh, have a great weekend. If you need any help, we could Zoom anytime you want to, day, night, or weekend. I'm at your disposition. Okay, everybody. Have a good day. Have a good weekend.
Great, thank you.
You're welcome. Bye.